Alright YouTube, so I had this idea. This broken wine fridge, I was able to trace it down to a broken computer board. So the computer board is saying that the evaporator defrost sensor is bad, but I tested it and it is not bad for sure. So what I was thinking was, rather than spending $75 to replace this computer board, I think I'm going to make something out of a Raspberry Pi. So all I really need to do is read the inputs of these temperature sensors and control 120 volt AC to this connector. Pretty easy to do. Just get a relay board, put that on top of the Raspberry Pi, write a little bit of software, and good to go. I already confirmed that the compressor runs. I did that pretty easily by, and I'll show you how I did that here. Turn the fluke meter on here. So we got nothing right now. I'll plug it in and you'll see we'll get 120 volts. And the compressor will be running. So I don't know if you heard it, but you see now we have 120 volts. So I got power connected from the hot and the neutral. Got these little alligator clips running over to this connector right here. And if we go over to the back of the unit, you'll see the condenser fan is running. I don't know if you can hear it, but the compressor is running as well. And I verified that the evaporator coil gets cool, so we know the refrigeration side is working correctly. So all we really need to do then is just come up with a simple circuit to control when the compressor comes on via this connector here, and also control when the evaporator fans come on through one of these two connectors right here. I forget which one it is, but it's all labeled. So this could be a neat little project. A lot of potential. Obviously the Raspberry Pi is a full-blown computer, so not only are we going to be doing just simple control of the compressor and the condenser fan, but we can do other stuff like alerts. We can do temperature alerts. We can do perhaps even wine orders through a REST API. So a lot of potential here. I did order a Raspberry Pi Zero. Actually a Raspberry Pi Zero W, which is really tiny. It's a 1 gigahertz processor with 512 megabytes of RAM. You can see how small it is. It's tiny. That's about 10 bucks. Next to it right there is an analog digital converter that we'll use to read the temperature sensors. That was about 8 bucks. And I have a relay board that should be delivered today that we'll use to control the compressor. And I believe that's rated for 10 or 15 amps at 120 volts AC. So that should work perfectly. This should be a pretty easy circuit to assemble. I'll have to solder on the GPIO header right here. You can see it's not populated. It's just a bunch of holes. I'll have to solder on that header. I'll have a bag of those headers in this bag here. So, a lot of soldering, but I think it's worth it. So hopefully we can have something working pretty soon. I'll have to develop, or I guess figure out, what the temperature function is for those sensors. I believe they're both negative temperature coefficient sensors, which means that as the temperature goes up, the resistance goes down. So what I'll do is I'll use water that's a known temperature, and I have my fluke meter with a temperature probe that I can use. This meter right here that we're using to just look at the voltage also has a temperature function that's, I think, accurate to within 1/10 of a degree. So what I'll do is, I know that this fridge, these temperature sensors are probably calibrated to operate within a pretty narrow temperature range. I'll start at like maybe 70 degrees Fahrenheit, then 50, then 40, then 30, and I'll note the resistance at each of those points. And from there we can use statistics to use regression analysis to figure out what function we can use to predict the resistance. And that should give us a pretty accurate way to figure out what the temperature is in here. For those of you guys that aren't familiar with statistics or regression analysis, Excel can do that. The TI-89 graphing calculator from the 90s can do that. So all you need to give it is a couple of data points, and it can produce a mathematical equation that will predict the values in between those data points and also beyond those data points. So it's a very, very useful technique. And once we have something ready to go, I'll shoot another video.